Hello, Math 8, welcome! All right, today we're going to work on how to solve systems of literal equations through graphing. So go ahead, grab a piece of paper, a whiteboard, something to write with, something to write on. Go ahead, give this warm-up a try. Pause your video. All right, here is our answer. So the solution is at -3,3, right? Remember, it is the point where our two lines intersect. Hopefully you got that one. All right, our goal for today is that I can solve systems of literal equations through graphing. And our learner right and responsibility is to be open to embracing errors. Remember that we're still learning, so making mistakes is totally part of that. And when you make mistakes, that's fine because we have to learn from them. We reflect and we learn better that way. So make mistakes and be proud. All right, so last class we discussed how to find solutions of equations by graphing. Today we're going to kick it up a notch. But first, what is a literal equation? A literal equation is an equation that has more than one variable in it. So we can have an x and a y in our equation, we can have a y and a z, we can have a p and a q and an x. As long as we have more than one variable, it's a literal equation. Now you're going to do a lot more with literal equations next year in algebra. We're just going to keep it pretty simple for today. So let's start by working on this one. As we can see, we have that 3y equals 4x plus 9 and 6y plus 18 equals -4x. So for both of these equations, we have an x and a y. All that we're going to do is get the y's all by themselves. So we're going to start with this 3y equals 4x plus 9. And our goal is to get y all by itself. In order to do that, we need to divide by 3. But when we divide, we need to make sure that we divide everything by 3. So this gets divided, this gets divided, this gets divided. Everything gets divided by 3. So we end up with y equals 4/3 x plus 3. Keep that 4/3 x just like that. Don't change it into a decimal. Don't make it an improper fraction. Nope, this is an improper fraction. Don't change it into a mixed number. Leave it like this because remember, that's our slope. That's our rise over run. So I'm going to graph my 3 and then I'm going to rise up 4 and run 3. And I can't do it again that way, so I'm going to go down 4 and left 3. I'm going to continue doing that until I have no more space, purely because we don't really know where our two lines are going to intersect with each other. So I want to have as many pretty points on here as I possibly can get. All right, so that's the first one. So our second one, I'm going to scoot over just a smidge. So here we have 6y plus 18 equals -4x. This one is a little bit more work involved because the y isn't already on one side with nothing else being added and subtracted to it. But just like our solving equations, this 6y is my circle of don't touch. So I need to get rid of that 18 by subtracting it from both sides. And I'm left with 6y equals, now, do not combine the -4x and the -18. They are not like terms. So I'm going to say -4x minus 18. I'm going to keep them separate because they're not like terms. I'm going to put that -4x first just because that's how we do it in our slope-intercept form. If you put that -18 first, that's totally fine. The form's just going to be a little different and it might confuse you. So now it looks similar to the previous problem where all we have left to do is divide, and we need to divide everything by 6. So this gets divided, this gets divided, and this gets divided. So here we're left with y equals, now this says -4/6x. However, 4 and 6 can both be reduced. So we need to reduce. 4 and 6 can both be divided by 2. So I'm going to end up with -2/3x minus 3. So that is our equation that we're actually going to graph. It's the same equation as before, we've just changed the form of it. When we work with literal equations, we're just changing the form, right? So now I know that I start down here at -3, and I'm going to go down 2 and to the right 3, and I'm going to continue that on 1, 2, 1, 2, 3. And then I clearly haven't actually hit my red line yet, so I need to go that opposite direction. So instead of going down and to the right, I'm going to go up and to the left. So up 2, left 3, up 2, left 3. And I'm going to connect all my dots together and pretend like I hit them. And so now I can see, let's use green. This point right here, this is where they're intersecting. And this point is at -3, -1. And so that is my solution. All right, hopefully that makes sense. I know it's a little weird, right? We're taking it from one form and we're changing it to another, and it's just strange. But we're just following our 3 commandments, right? Whatever you do to one side, you must do to the other. You can make any number 0 through addition or subtraction. You can make any number 1 through multiplication and division. That's all we're doing. We just aren't getting a solid like y equals 4 kind of answer when we deal with literal equations. All right. So now I want you to try. Go ahead, put these both into slope-intercept form. The first one's already there for you, so that's nice. So you're just taking that green equation, putting it into slope-intercept form, right? For the green equation, you want it to be y equals. Get that y all by itself. Go ahead, try that out, and pause the video. All right, so here is our solution. So I took my green equation, I put it into slope-intercept form, and I got y equals -3/5 x plus 7. I graphed both equations, and I realized the point where they intersected was at 0, 7, which was my y-intercept for both problems. So here is that solution for you. Go ahead, check your answer real quick. If you have something different, make sure you fix it. All right, now here's a challenge problem for you. Again, that first one is already in slope-intercept form, so go ahead, change that blue equation to be in y equals mx plus b, and see what happens. Go ahead, pause your video. All right, so here we are. I took my blue equation, I put it into slope-intercept form, and as you can see, I had x divided by 2. And when we have x divided by 2, it's the same exact thing as 1/2 x. So I just changed it into a more pretty form that we know how to work with. But what happened here? Right? As we can see, both of our lines are over top of each other. They're the same exact equation. When this happens, we say that we have infinitely many solutions, right? Remember, the solution is the point where our lines touch. And if it's the same exact line, it's always touching in every single spot that you could possibly imagine. There's an infinite number of possible solutions that you can have. So we say that our answer is infinitely many solutions, or IMS for short. Oh, yep, what happened? We talked about that. So now your closure for today is, what is the difference between infinitely many solutions and no solution? Last class we talked about no solution. And is there a way to tell a difference from the equations? And if so, what is that difference? Can you look at an equation and say this one's going to be infinitely many solutions, or this one is going to be no solutions? And if you can, tell me how. Go ahead, write that down, pause the video, and then that's the end. Have a lovely day, and I will see you later. Love you, bye.